Here in section 4, we're going to be looking at some special parallelograms. They're rhombuses, rectangles, and squares. So first, let's define them exactly what they are. A rhombus means that it's a parallelogram with exactly 4 congruent sides. A rectangle then has 4 right angles. Notice the definition is about the angles, nothing about opposite sides being congruent. Those are things we know because it's a parallelogram, but the definition is just that the 4 angles are right angles. A square then is a parallelogram with 4 congruent sides and 4 right angles. So we can think of a square as a rectangle and a rhombus at the same time. A square then would be a combination of the two. The first theorem we'll get are dealing with rhombuses, or some books will say rhombi. And if we draw the diagonals, notice that we're getting a right angle here. We'll always have a right angle from the diagonals in our rhombus. Another thing about the rhombus and the diagonals are the ways that the angles are formed. These 4 angles are all going to be the same. And if we look at the other side, these 4 angles, 1, 2, 6, and 5, will also all be the same. A different way. If I have a rhombus here, I notice that each side of this rhombus is basically an isosceles triangle as we see drawn up here, which means that my base angles are congruent. So I can mark that here. This angle and this angle are congruent. Since this is the same isosceles triangle, these two would also be congruent. And since the 2 triangles are congruent, all 4 of those angles are the same. Now we could also think about it going in the other direction. If I look at this triangle up here, it's isosceles as is the one down on this side, which for the same reason would give me base angles congruent here and here. So those 4 angles are also going to be congruent. So they're all bisecting each other. Now the other thing about this, then, notice I've got in all 4 of these angle, side, angle, where all those angles are congruent, which means I have 4 congruent triangles, which means I also have the same angles in each of these. Since all 4 of these angles are congruent, they have to all be 90-degree angles. Okay, we can also look at properties of rectangles. Their interesting property is about the diagonals. Now remember, with any parallelogram, our diagonals bisect each other, but with a rectangle, those diagonals are actually congruent. So what we have here, properties of rectangles, are all of our things that we know about parallelograms will be true, but then we're adding these 2 things. We know that all 4 angles are right angles and diagonals are congruent. And we could also add as a corollary to this one, since diagonals bisect each other and they're congruent, we can also look at each part of this, and each part of this would be congruent. Now for the proof of this, what we would do is redraw these triangles here. We would only need to use a couple of them because we're only worried about proving something about the diagonals being congruent. And I've got my diagonals if I look at these 2 overlapping triangles. Notice this is a reflexive property here between these 2 sides. Also, because it's a rectangle, we know we have 90-degree angles down here. And because it's a parallelogram, we have opposite sides congruent. So here we can see we have side angle side. These triangles are congruent. So by CPCTC, we know that AC is congruent to BD. The diagonals are congruent to each other. Okay, so if I want to find my diagonal length, they tell me it's a rectangle, so I know SF is equal to RB. And so I just take the values they give me and set them equal to each other. I solve it, and I get x equals 9. Now we want to be careful here and read the question carefully. They asked for the length of the diagonal. I've just marked 9. I haven't really answered the question. I've just given the value of x. We want to look up here, they want the length of each diagonal, so I need to actually plug this in to either one. Since they're the same, it doesn't matter which one. So let's go with SF is equal to 2 times 9 plus 15, which gives me 18 plus 15, which is 33. It would be the same for RB, and that would be 33. In the first one, it looks like there's not enough marked, but they did tell us that this is a parallelogram. If it's a parallelogram, then opposite sides are congruent. Those 2 are the same, and these 2 are the same. So it's a rhombus. Also notice that we have a 90-degree angle here, which means that's 90 degrees because they have to be supplementary. Opposite angles are also congruent. So this one's actually a square. The next one, we have 4 congruent sides, but we do not have 90-degree angles, so this one's a rhombus. The third question asks about measures of numbered angles in the rhombus. So the numbered angles, we would look here. Remember, our property is that these diagonals bisect here. So the measure of angle 3 would be the same as the one next to it, 50 degrees. The measure of angle 2 is going to be the next one that's easy to find. Since it's a rhombus, we know that all these angles in the middle have to be 90 degrees. So that one's 90. Okay, that leads us to angle 1, which we'll have to do a little bit of work to find. But notice what we've got here, a bunch of right triangles. We've already found that this is 50 degrees over here, so 50, 90. That leaves us with 40 degrees for our third angle.